Welcome to GrayYeon Math. We are asked to solve this problem. We have a circle, and uh, in this, with this circle, we have a triangle that overlaps the circle, and the legs of this right triangle, as you can see, this is a right triangle with one angle as 90 degrees, and the one leg of this uh, right triangle, a secant, extends by one unit, and another secant, which is the other leg of the right triangle, extends the secant by 3 units outside the circle, and a line is drawn inside this circle which passes through the center of the circle, and the center is that line is actually forms a region with the legs of this right triangle inside the circle, and that is the blue region, this blue region, and we are required to find the area of that blue triangle. Okay, so first thing that I want you to notice is that these two segments and this segment actually passes through the center of the circle, the center. And if that is the case, then we can actually say that the diagonals of this, if we draw a line from this point to this point, and this point to this point, we actually form a rectangle. And these diagonals divide the rectangle into two. I mean this diagonal divides the rectangle into two equal parts. So this is equal to this part equal to this part. So as you can see, if that this diagonal divides this rectangle, then this area, this triangle is half of this rectangle. This blue region is half of this. Uh, let's say that the area of the rectangle is A, then this is A over 2, and this is A over 2. Okay, so since this blue line that we have drawn is perpendicular with this by Thales theorem. Okay, so if you actually, I want to take this opportunity to prove Thales theorem and to prove that this angle is really 90 degrees. Okay, so let us start with this angle. So if this is alpha and this angle, we call this as beta. Okay, so and we take note of this side as R, and this side is also the radius since this is from the center to a point on the circle, and this is also from the center to this point is also the radius. Okay, so if we focus on this triangle, this only, then this, since this is R and this is R, this triangle is actually an isosceles triangle. Okay, so this triangle is an isosceles. So this angle is beta. Okay. And next is we focus on this triangle. if this is alpha, and since this is R and this is R, then we have an isosceles triangle. So if we have this isosceles triangle, if this is alpha, then this angle is also alpha. Okay, so next is we focus on this combination of the blue and the green. Okay, so in any triangle, the sum of the angles is actually equal to 180 degrees. So if we focus on this blue part, so we have beta plus beta plus this green, we have alpha plus alpha. So we have alpha plus alpha is equal to 180 degrees for all triangles. So we can actually add this and we may say that 2 beta plus 2 alpha is equal to 180 degrees. And we can factor out 2. So we have 2 times beta plus alpha is equal to 180. So if we divide both sides by 2, we cancel this and we have beta plus alpha is equal to 90 degrees. And as you can see, this angle is actually beta plus alpha. And as we have calculated, beta plus alpha is equal to 90. And this angle is opposite the diameter. So this is 90 degrees. Okay, so now that we have proven that this angle is 90 degrees for this angle, and since this quadrilateral is inside a circle, so the opposite angle for this angle is and this should be 100 opposite, the sum of the opposite should be 180 degrees. So if the opposite sum is 180, then this should be 90, and since this is 90, this should be 90 also, and therefore we can say that this line is parallel to this line, and also this segment is parallel to this segment. Okay, they are not actually congruent. The two, this one is not congruent with this one, but the two opposite sides are parallel. Okay, so next is we label this segment as A, and the other segment is B. So this will be A. We desire it to be A, and this will be B. So since we are after the area of this blue region, this is a right triangle. Actually, then we have area is equal to 1/2 times AB. So that is the area that we desire. So, and if this is A, then this is also A. And if this is B, then this is also B. Since this is a rectangle, they are parallel and also congruent. Okay, so since this segment B is parallel with this segment, okay, and it should be also parallel to this segment. This smaller segment is parallel to this. Okay, because actually their angle is the same. So say this is theta. This should be theta also. Actually, these two triangles are actually similar. So we actually need to compare this and this to get a relationship between A and B. Okay. Okay, for the larger triangle, that is B the larger, then we compare this. I mean, with reference to theta, the opposite is A. Opposite of angle theta is A. over the adjacent is 3 is equal to a ratio which is of course that should have the same angle theta, which is this triangle. So theta, this angle, the opposite side is 1 unit and the adjacent side is b. Okay. So actually, we just need to cross multiply. So we have here AB is equal to 3. And earlier we have said that the area is equal to 1 half times AB, but AB is actually equal to 3. So we just substitute the value of AB, which is 3. So we have the area is equal to 3 over 2 square units. And that is our answer for the area of the blue region. So thank you for watching until the end of the video. Please like the video if you liked our solution and don't forget to subscribe to the channel and hit the bell icon so you will be updated for more math videos like this. Thank you. Bye.